Hello everybody and welcome to the second 5.2 video over simplifying trig expressions. And this video is going to combine the previous two. We want to again solve a puzzle. And we want to use our algebra skills to help us, as well as the trig identities we talked about in the first video. So when we solve these puzzles, there's two things we want to consider. The first thing we always want to consider is, do I see a trig identity that I can replace? And if I don't see a trig identity, then I rely on my algebra skills. So to be a little bit more thorough on that, substituting identity strategies. If you recognize any identities from the front of your notes packet, use them. They may help. So the reciprocal identities. If you see something like 1 over secant, maybe replacing it with cosine would help you. If you see sine over cosine, replacing that with tangent, or if you see tangent and you think it would help you to replace that with sine over cosine, that could be useful. Anytime you see something that's squared, I would consider the Pythagorean identities. Cofunction identities come up occasionally. They will come up in this video, but these are sometimes useful, as well as the even-odd identities. I would say that from my experience, these three identities up here happen or occur much more often than these two. So just please keep them in mind as we're going through the examples today. If all else fails, you generally want to change everything to sine and cosine, or use a lot of these identities up here. And you'll see what I mean by that as we go through. Let's say you look at a problem, though, and you don't see an identity right away. What we talked about in the last video is some algebraic strategies, and I'm going to talk about a few more. So one strategy we could do is distribute or multiply. Like if I give you sine of x plus 1 times secant of x minus cosine of x. If you don't see any identities right away, you can go ahead and distribute or FOIL like we did in the last video. That's an option. You could combine fractions. So if I gave you 1 over cosine of x minus sine of x over, I don't know, cosecant of x. What you could do is get a common denominator. This fraction would need the cosecant of x on top and bottom, and this fraction would need the cosine of x on top and bottom. Something like that is an option. Multiplying by 1, what that means is, let me bring it down here, is if I have something like 1 over cosine of x, which is a popular one I keep picking, if I don't know what to do with that, we could always multiply by a 1. Now, I don't mean an actual 1. The reason it's in quotations is, remember, anything divided by itself is 1. So let's say I wanted to multiply top and bottom by sine of x. Now I just made that up, but if you multiplied by sine of x over sine of x, that's really equal to 1, and it would change what this problem looks like, which could help you solve a puzzle. We could split fractions. So if I gave you sine squared of x minus 1 over cosine of x, we could make that into sine squared of x over cosine of x minus 1 over cosine of x. Something like that could help you. And last but not least, something you might remember from algebra and geometry is the idea of the conjugate. If I gave you sine of x over 1 minus cosine of x, it doesn't look like there's any identities here. So what we could do is multiply top and bottom by the conjugate, which would be 1 plus cosine of x, and then another 1 plus cosine of x. Because if we took the conjugate on the bottom, we would possibly help us reduce. So all of these strategies will be useful. So let's dive into some examples and see where this takes us. So the first one, I'm going to take these step by step to get into my thought process. When I look at tangent of x times cosecant of x, I look back at my identities and say, do I have any Pythagorean identities? No, I don't have any squared functions, so that's not going to help. Do I have any cofunctions with the pi over 2 minus theta? No. Do I have any negative angles? No. So it's possible that if I was going to use a trig identity, it might be one of these two that could help us. So let's look back. I want to somehow reduce this as much as possible. And so what I think about is, when I look at tangent, a good last resort is changing things to sine and cosine if you don't know what else to do. I know from the identities that tangent is equal to sine over cosine. So if I took tangent and replaced it with sine of x over cosine of x times Cosecant of x, if I go back to my identities, cosecant of x, which is here, is really the same as 1 over sine. The reason I like that is if I replace this with 1 over sine of x, is I can see now that I can cross cancel. If I have a sine on the top and the sine on the bottom and I'm multiplying, these cross out. So I'm left with 1 over cosine of x. Now the question is, did I simplify it? Yes, I did. But could I simplify it more? I could. Because if I go back here a third time, 1 over cosine of theta is really the same thing as just secant of theta, and that is the most reduced version we could say. So the final answer for this is secant of theta. And so that's what I mean by replacing sine and cosine as a last resort. It does work. Sometimes it's a slower method, but it does generally come through. The second one, it's really tempting to say, let me distribute the cosecant of x in. And if you did that, you probably would get the answer right. But my focus of this video is to encourage you to look at the identities first. So let's go back to our identities. Or before I do, I noticed that one of my terms is squared. So I look back and notice my Pythagorean identities. And the Pythagorean identity that has a cosine squared in it is this first one. Sine squared plus cosine squared equals 1. So I'm going to go back over here above this and write that. Sine squared x plus cosine squared x equals 1. Now this does not match this identity exactly. However, if I manipulated this identity and I matched this with this, if I subtracted the cosine squared x to the other side, I would get that sine squared x is equal to 1 minus cosine squared x. And now I can do some substitution. I now know that sine of x is equal to 1 minus cosine of x. So I can replace this with just sine squared of x now. And that is still being multiplied by cosecant of x. And so that is where a Pythagorean identity comes to help make it more simple first. Now, I want to try to get this down to a single trig function if possible. So I look at this and I remember that sine and cosecant are reciprocals. So let's use that to our advantage. Let's try to change this problem all to the same trig function if possible. So I know that cosecant of x, if I go back, cosecant of x is really equal to 1 over sine of x. So if I replace this with 1 over sine of x, that's useful because sine squared is really equal to sine of x times another sine of x. So what happens is that one pair of the sine x's cross out, and so my final answer is just sine of x. It would be a good idea at some point, by the way, to redo these on your own without looking at the video, because again, as I said, they are puzzles, and you could look at this a very different way than myself and see if you get the same answer. It's a good practice for you. Simplify this expression. Now, when I see this, my mind goes straight to identities. Specifically, it goes to these cofunction identities. Sine of pi over 2 minus theta is equal to cosine, and cosine of pi over 2 minus theta is equal to sine. So I'm going to use that, make this more simple. I'm going to replace the top with just cosine of x from my identity sheet, and I'm going to replace the denominator with sine of x. Great, I made it a little bit more simple, but the question is, am I done? I see one more thing we can do. If I look back at my identity sheet, right here, I know that cosine divided by sine is really the same thing as cotangent. So that means that this just reduces to cotangent of x. Again, a single trig function, if possible. Hurrah! By the way, I'm sorry I had to do this. Sine gerene divided by cosine gerene equals tangerine. I'm sorry, I'm not sorry. That's amazing. Anyway, simplify the trigonometric expression. So this time is the first time we have a plus sign going on here. So let's think about possible algebra strategies. Because I'm adding, can I get a common denominator? Well, no, because the denominator of all of these is already 1, so that won't help us. Are these like terms? Can I add them? No. Can I multiply anything? Is there anything to distribute? No. Can I use a reciprocal? Can I multiply by the conjugate? No. So that makes me think that, as I said before, let's focus on using the trig identities first before we think about algebra skills. And so when I look at this, my goal is to try to get this to be all one trig function, or try to get it in some way where the trig functions can be the same and cross out in some way. So I'm just going to go with my gut and replace things with what I know. For instance, I know that cosecant is really 1 over sine. So I'm going to replace this with 1 over sine. I'm just going to use x instead of this symbol just to make it easier. Tangent of x. We can go a lot of different ways with this one, but the one that tends to come to our aid quite a bit is right here. Tangent of x or theta is sine over cosine. So I'm going to use that quotient identity. I'm going to replace this with sine of x over cosine of x. And I like this already because I notice these signs are going to cross out, so that is great. For now, I'm going to keep this just as secant of x because I'm not multiplying it by anything. So this side, I'm going to cross out the sine of x's, and I'm going to make this 1 over cosine of x plus secant of x. Now, because this has a denominator and this doesn't, we could try to get a common denominator here. However, try to focus on your identities first. These reciprocal identities, I'm sure you've noticed, have come in handy so many times. I have 1 over cosine of x. 1 over cosine of x is really the same as secant of x, or secant of theta. So I can replace this with secant of theta, or x, plus another secant of x. So that means that my answer is just 2 of them, 2 secant of x. Simplify this trig expression. Now this is one that I'm going to pause, and I want you to try on your own first. My suggestion would be any trig function that you don't like sine's a decent one. If you don't like secant and cotangent, change them to something that you recognize. Try reciprocals, try the quotient identities. I wouldn't do the Pythagorean because we don't have anything squared. So try this one, and I will come back with my answer. So please pause now. All right, so let me check in with you and see if anybody did the same thing as me. I left sine alone because I like sine, cosine, and tangent if possible. Secant, I changed to 1 over cosine, and cotangent, using the quotient identity, I changed to cosine over sine. The reason I love this is I see some definite things we can cross out. This is really over 1. This cosine and this cosine cross out because we're only multiplying, not adding or subtracting. And same with these sines. This sine of theta, because it's on the numerator, cancels out this sine because it's in the denominator. So the only thing I'm left with is 1 over 1. So my final answer is just the number 1. I love that problem when it simplifies just to a number. Feels really satisfying, I'd have to say. Simplify this trig expression. Okay, so do I see any identities I could use? Well, I could replace secant with 1 over cosine. I could replace tangent with sine over cosine. That's a start. I don't see anything squared. I'm going to leave the sine alone this time because I generally like it more. So let's start with that. Let's see if that gets us anywhere. I'm going to replace secant with 1 over cosine of, this is technically a beta, minus sine of beta, which is another name for an angle, times tangent, I'm going to replace with sine of beta over cosine of beta because of this identity here. Okay, let's see if that got me anywhere. So this is still 1 over cosine of beta minus, this is really over 1. So if I multiply these two, I get sine squared beta, because there's 2 of them, over cosine of beta. Now this may look like I made it more complicated, but good news, it's actually going to work out. I don't have enough time in this video, so I'm going to finish this problem and the next problem in a shorter second video. So please join me there. Thank you.